Hi everybody, welcome to part 2 of the review. We're going to talk about the Pythagorean theorem converse. Again, this lesson, at least for Mr. Collins, I think for everybody, was a few Wednesdays ago. It was a Wednesday right before we started our trigonometry unit. And so if you haven't gone and done that lesson, go back, check out. Say may not make sense unless you actually have taken the notes and done that practice. Okay, because I'm not going to go and necessarily explain every individual thought process, but I am going to go over the results. And so if there's some confusion, first go back and finish that lessons before you go talk to one of your teachers, okay? So with that being said, directions clearly are given this triangle, whether in picture form or just given the side lengths, determine using the Pythagorean theorem converse whether this is a right triangle. Well, per the notes, we don't know this is a right triangle, but it certainly appears that it could be. And so we're going to test it using the Pythagorean theorem. If it was a right triangle, then these three values should fit perfectly within the Pythagorean theorem. If it's not, then we get to make a decision about it being either right or acute, but certainly not, acute or obtuse, but certainly not right. So for my potential A and B, I should still use my two smallest sides. So I have 9 squared plus 12 squared. And I should compare that against my longest side, which is 15. Then 15 would be my hypotenuse. 9 squared is 81. 12 squared is 141. And I should test that against 15 squared, which is 225. Okay? 81 plus 41, I don't want to mess this up, so let me grab my calculator. So 81 plus 141 is equal to 222. Okay? Whereas the potential hypotenuse squared is 225. And so since these are not equal, I know for sure this is not a right triangle. Okay? And since the c squared value is too large, I also know it's actually obtuse. All right, so now we can repeat that process. So we test first, assuming that it's going to be a right triangle. Okay, so my two smallest sides, 39 and 32.5, go in for A and B. And then 48.5, my longest side, goes in for my potential hypotenuse. Okay, so 39 squared gives me 1521. 32.5. 0.5 squared. Okay. These are not equal. $15 squared is 225. Is 1296. definitely let's test this. Square it. And then 2. Okay, so here we have an example, a squared plus b squared. It is exactly b squared. In Pythagorean converse, we're of course going to assume the triangle. So we can plus b squared equals c squared, putting our 2 smallest values in for a and b, our largest in for c, because that's the potential hypotenuse. Work down the problem and then compare a squared plus b squared against c squared. If they're the same, it's going to be a right triangle. If not, it'll either be acute or it'll be obtuse. Okay. So page 2 of practice, same deal. So we're going to Pythagorean theorem. We'll use our 2 smallest values for a and b because those have to be the legs, not the hypotenuse. And so I have 9 squared plus 12 squared. In this case, testing against our largest value, 17 squared. Okay, so 9 squared is 81. That's going to be 144. 17 squared. My color scheme, but that's okay. 2 smallest sides, 9.6 and 18, go in for A and B. Largest potential value for hypotenuse, 20.1. Okay, so 9.6 squared plus 18 squared will give me 416.16. Compare that to 20.1 squared. That's 404.01. Okay, so again, we have a non-equality. So not a right triangle. Okay, in this case, these 416 is only 404. It's too small, so it's an acute triangle. Without the triangles, but that's okay. Our methodology does not change. So this looks like largest value, 29.